Imagine a world shrouded in mystery. This was Europe before the 17th century. Knowledge was intertwined with superstition. Ancient texts and religious dogma held sway. The natural world was often seen through the lens of myth and folklore. This era, however, was about to change dramatically. A new age of reason was dawning, the scientific revolution. For centuries, the writings of ancient Greek philosophers, particularly Aristotle, were considered the ultimate authority on matters of science. Their works were meticulously studied and revered, forming the bedrock of intellectual thought. Aristotle's observations and theories shaped the way people understood the natural world, influencing countless generations of scholars and thinkers. The Church's teachings also held immense influence. During the medieval period, the Church was the central institution in society, guiding not only spiritual matters but also intellectual pursuits. Its doctrines were intertwined with the prevailing scientific views, creating a unified framework of understanding. The universe was seen as a divinely created order, with Earth at its center. This geocentric model, proposed by Ptolemy and endorsed by the Church, depicted a cosmos where all celestial bodies revolved around a stationary Earth, reflecting a harmonious and purposeful design. Natural phenomena were often attributed to the will of God or the influence of celestial bodies. Events like eclipses, comets, and even weather patterns were seen as manifestations of divine will or celestial influence, reinforcing the interconnectedness of the heavens and the Earth. This geocentric model, with Earth as the focal point, was deeply ingrained in the medieval mindset. It provided a sense of order and purpose, aligning with the religious belief that humanity held a special place in the universe. It reinforced the idea of humanity's central place in creation. The belief that humans were at the center of God's creation gave people a profound sense of significance and responsibility within the grand cosmic scheme. Questioning these established views was often met with resistance from both religious and academic authorities. Scholars who proposed alternative theories or challenged the geocentric model faced significant opposition, as these ideas threatened the established order and the Church's authority. Before the scientific revolution, the study of nature was known as natural philosophy. It was a blend of observation, philosophical reasoning, and religious belief. Natural philosophers sought to explain the world around them. However, their methods often lacked the rigor of modern science. Experimentation was not yet a systematic practice. Conclusions were often drawn from anecdotal evidence or philosophical arguments. While some ancient thinkers, like the Greek astronomer Aristarchus, had proposed heliocentric models, these ideas were largely dismissed in favor of the prevailing geocentric view. The scientific revolution marked a radical departure from the reliance on ancient texts and religious dogma. It ushered in an era of empirical observation and inductive reasoning. Scientists began to question accepted truths, demanding evidence and conducting experiments to test their hypotheses. This emphasis on observation and experimentation transformed the way knowledge was acquired. It shifted the focus from speculation to verifiable evidence. The world was no longer to be understood solely through the lens of ancient wisdom, but through direct observation and rigorous testing. Section 5. Pioneers of the Scientific Revolution, Galileo Galilei. A man whose contributions to science and astronomy were nothing short of revolutionary. One of the most iconic figures of this era was Galileo Galilei. His work laid the foundation for modern physics and observational astronomy. Born in Italy in 1564, Galileo was a mathematician, a scholar who excelled in various fields of study, astronomer and physicist. His insatiable curiosity and innovative thinking led him to make discoveries that would change the world. He made groundbreaking observations that challenged the geocentric model of the universe, which was widely accepted at the time. Using the newly invented telescope, Galileo was able to see celestial bodies in unprecedented detail. He observed the moons of Jupiter. This was a monumental discovery, as it provided clear evidence that not all celestial bodies orbited the Earth. Galileo's observations provided compelling evidence for the heliocentric model proposed by Nicholas Copernicus. This model suggested that the Earth and other planets orbited the Sun. His work, however, brought him into conflict with the Catholic Church. The Church held the geocentric view as a core part of its teachings. He was accused of heresy, a serious charge that could lead to severe punishment, and forced to recant his views. Despite facing persecution, Galileo continued his work in secret. Galileo's work helped to shift the scientific paradigm. His legacy lives on, inspiring generations of scientists and thinkers to question, explore, and discover. Section 6. Isaac Newton, Unveiling the Universe's Secrets. Isaac Newton, born in England in 1643, was another towering figure of the scientific revolution. A mathematician, physicist, astronomer, and alchemist, Newton's contributions to science are immeasurable. His book laid the foundations for classical mechanics. In it, Newton formulated his three laws of motion. These laws described the relationship between an object and the forces acting upon it, revolutionizing our understanding of motion and gravity. Newton also developed calculus, a powerful mathematical tool that became essential for scientific advancement. Section 7. A universe governed by laws, the dawn of modern physics. Newton's work led to the understanding that the universe is governed by natural laws. These laws are discoverable through observation and experimentation. This realization was a cornerstone of the scientific revolution. It empowered scientists to study the natural world with a new sense of purpose and precision. The universe was no longer seen as an unpredictable realm subject to the whims of deities. It was a cosmos governed by principles that could be deciphered through reason and empirical investigation. Section 8. Early discoveries, shaping our understanding of the world. The scientific revolution was a period of remarkable discovery. William Harvey, an English physician, described the circulatory system and the heart's role in pumping blood throughout the body. Robert Hooke, an English scientist, discovered cells using a microscope. These discoveries, among many others, expanded our knowledge of the human body and the natural world. They laid the groundwork for future advancements in medicine, biology, and other scientific disciplines. Section 9. The enduring legacy, the scientific method. Perhaps the most enduring legacy of the scientific revolution is the development of the scientific method. This systematic approach to inquiry involves observation, hypothesis formation, experimentation, data analysis, and conclusion. It provides a framework for gaining objective knowledge about the natural world. The scientific method is not a rigid set of rules. It is a dynamic process that evolves with new discoveries and technologies. It encourages skepticism, critical thinking, and the constant re-evaluation of knowledge based on new evidence. Section 10. From Revolution to Evolution, the unending quest for knowledge. The scientific revolution did not end abruptly. It marked the beginning of an ongoing process of scientific inquiry and discovery. The 18th century saw the rise of the Enlightenment, a philosophical movement that emphasized reason, individualism, and human progress. The Enlightenment drew inspiration from the scientific revolution. It applied scientific thinking to fields like politics, economics, and social reform. This period witnessed the rise of scientific societies and journals, fostering collaboration and the dissemination of knowledge. Section 11. The Scientific Revolution and the Modern World. The scientific revolution was a watershed moment in human history, marking a profound transformation in our approach to understanding the natural world. It reshaped our understanding of the universe and our place within it, challenging long-held beliefs and paving the way for new discoveries. This period laid the foundation for modern science and technology, introducing methods and principles that continue to guide scientific inquiry today. The scientific method born out of this revolution continues to shape our world today. It emphasizes observation, experimentation, and the formulation of theories based on evidence. From medical breakthroughs to technological innovations, the principles established during the scientific revolution have led to countless advancements. The impact of the scientific revolution is evident in every aspect of our lives. It has influenced fields as diverse as physics, chemistry, biology, and engineering. It taught us to question, to explore, and to seek answers through observation and reason. This spirit of inquiry has driven progress and innovation for centuries. The scientific revolution is a testament to the power of human curiosity and our enduring quest to comprehend the cosmos and our place within its grand tapestry. It reminds us that the pursuit of knowledge is a never-ending journey, one that continues to inspire and challenge us to this day.